So today I'm going to be talking about the grammar of graphics. If you actually look on our prior talks, I have given this talk much like this talk, talk like this, pretty much exactly like this before. And in that, I've talked about the grammar of graphics inside of R, which is where the grammar of graphics originated. Today, I'm going to be doing it again, but I'm going to be using Python. Python tends to be a little more popular with our users. It's kind of the hot language at the moment. So it'd be useful to see it for our grammar graphics package. So what is the grammar of graphics? The grammar of graphics is a way of trying to describe a graphics. So what the goal of the grammar graphics was to make it very easy to express yourself, sort of like how we would describe a plot, and then have the computer present that. And so there was a couple goals. Again, just basically what I said. And it actually has a long history. There was some papers written about it. In '83, we got the semiology of graphics, and then in 2005, that was revised to the grammar of graphics, and then in 2010, it was the layered grammar graphics. Wickham being the famous person behind the R tidyverse packages, which include the grammar graphics, and ggplot was grammar graphics plot. Wrote that package, and then it got ported over to Python at some point as Plotnine. So what does this grammar graphics look like? Well, basically you call a ggplot function, you pass it your data, and then you call variety of geometry functions, which put geometry on it, and then you can adjust the coordinate and you can facet it. We'll look at that later. You can adjust the scales, put on guides. Guides are like little boxes that give you your legends and stuff like that. And then there's a theming option. So basically you just build it up with as many components as you want. And there's a really nice aspect to this is it's a sort of an iterative thing. You can make your plot up as you go, and then you can go back and refine it and add more to it. So back in this prior one here, we mentioned the data was the data, the geometry function. This is the aesthetics, they call them. The statistics that are performed, and some pushing position stuff. So the data is the underlying data, and you can plot many bits of data or from multiple data sorts, and they all just kind of combine on the same graph. The statistics is the underlying statistics transformation of that data. Quite frequently, like for example, if you're doing bar charts, you'll be actually plotting counts of your data, or if you're plotting a bunch of scatter points, you might want to plot a line of best fit. So that's the sort of stats transformations that are done. The geometric objects to represent the information. So you can represent it as bars, you can represent it as points, you can represent it as all sorts. There's a huge pile of geometry functions. Mapping, so the data is generally numerical or categories, and then how that gets mapped to things that you actually see in the graph. So like how colors get picked, how positions get picked. The most frequent mapping, of course, is what data value gets mapped to X and which data map value gets mapped to Y, which are the coordinates. But there's also all sorts of other things, colors, size, fonts, scales. You can all map to various data functions. The coordinate function, of course, underlying a plot has to be a coordinate function. So there can be like log coordinates, there can be Cartesian coordinates, there can be polar coordinates, and so on. Positioning is a little bit of positioning tweak. A typical example might be bar graphs. You can have them stacked or you can have them side by side. Sometimes it helps to jitter the points a bit, so just bump them around so they don't overlay each other. The facet function has the ability to split the plot into subplots. So the same plot, but just different categories of the data. I find that really super useful. And then the scale function, so how the data are translated to visual properties. So like, is it a color scale? Is it a discrete scale? And so on and so forth. And then the guides are actually the boxes that'll show you your scales, and the information about them, like an axis label with the intervals marked off on it, or it could be a series of colors that are a series of dots of different sizes and what values those correspond to. And then the theme function, which controls basically how all the little, all the, well, yeah, it basically lets you theme it. So as I said, there's two implementations. There's ggplot, now ggplot2 for quite some time, which was Wickham's original implementation, and now there's the Python Plotnine. There's some great books from the R perspective, ggplot2, the book, and R for Data Scientists. Highly recommended. As you'll see, there's not a whole lot of difference between the R and the Python, so you can very much use these books. I'll just click on this here to bring it up. Actually, I'll just copy this link. So you can buy this book on Amazon, or you can just read it all online here. It has the whole sort of details, highly recommended. And then if you actually are using R for Data Scientists is as an excellent introduction to it. It covers ggplot, but it also goes into the R equivalent of what would be pandas, which I have to say is actually better than pandas. So personally, I use Python if I need to use some other library that's only available in Python. Otherwise, I do my data science visualization and sloping in R, not particularly because I love R, but because ggplot and the rest of the tidyverse that goes with it is so nice. So let's just get into creating a plot. We're going to be using, I've got an R window and a Python window up here so we can see. So if it was an R, we'd have to load the library tidyverse. Pull that in, which gives me the ggplot and then the equivalent of pandas. And it also gives me some sample data sets. So we got the MPG miles per gallon data set here. I'll just adjust my window a bit. There we go, which is the data set we want to be. So I'm just going to write this out to a CSV file. X, yes. So write MPG out to, and then the file will be mpg.csv. There we go. So now on the Python side here, we want to bring in the Plotnine library and the pandas. So I'm just going to say import. Sorry, I want to bring it in. I'm just going to bring it in at top level. So from Plotnine, import everything. From pandas, import everything. Okay, and then we'll just suck back in that MPG data set. MPG equals read CSV and MPG.CSV. And there again is the same data set, except for now we have it in Python. Now, before I go any further, I'm just going to show you just down here how you'd actually install pandas. This is just off my machine here, but here's how you could do it at the cluster. So I will secure shell into Graham. So login as Tyson, graham.compute canada.ca. Uses my SSH key there to log in, and some one-factor authentication stuff. There we go. So now you can install anywhere on the cluster, but I'm going to put it into my projects folder. So I'm just going to go into projects, the default Tyson projects, and it's a Python package. So we just load the Python module load Python. There we go. And to run it, we just do the virtual environment. And we can call it whatever we want. I'll just call it Plotnine. And what this does is this just creates a directory, Plotnine, under which all the packages and stuff are installed. So I want to activate that virtual environment. So I source the Plotnine inside there. Now there'll be a bin activate. This Plotnine here is just because maybe the Plotnine wasn't the best name. So virtualenv created a folder called Plotnine, for which everything's going inside. So inside there in the executables, I'm going to run the activate command. Now you can see I'm inside the Plotnine virtual environment. So now if I do a pip install, and I'm just following the directions here, let me bring them up as well. So we want to look at docs, lines can ca virtual and just exactly following this this set of directions here on creating a virtual environment. So the command I'm now on is this one here. So we want to install, and we don't want to download it. We just want to use the latest one we make available and upgrade our pip, which is the Python package installer, Python, whatever. Python install packages, maybe. Package installer for Python. So there we go. So it's upgraded it here from version 20 to 23. And now we just say pip install, and we say Plotnine. And that'll go and that'll download or pull it from our wheels. And that's it. So once that's done there, I can fire up Python. As long as I have that environment activated, it will have available into it any of the stuff that I have installed in via pip. And of course, you can have multiple environments. The nice thing is when I deactivate this environment, then those things go away, right? So they won't conflict with my other libraries. So Python virtual environment is very nice. So it's just installing these packages here. So anyways, while that's completing, let's go on to the next one here. So let's have a quick look at an ordinary plot here. So ggplot is the command to start the plot, if you remember right. And my data is going to be equal to my miles per gallon data set. And this just basically, ggplot sort of creates the base object, and then you can set a number of defaults for it. So you can just call ggplot with nothing, and then we want to add. So now that we specified a plot, we want to add to it. And the thing you first want to add is some geometry. So if we look at this geometry, this is point data, basically. And there's a function for that. If we go geom point, you can see here, actually, I've got tab completion. I had mentioned there was a lot of geometries. You can see some of the various geometries you can put on. And people often make the mistake, they say, oh, I want to do something with, points with air bars. Where is that? But that's actually in ggplot, that's a combination. That'd be like a point plus plus another item in here. And I'd have to spend some time looking that up. They're a point plus some air bars, and you'd add those as separate geometries to the same plot. So it's very much about composing your plots. So anyways, geom point. Now, if I hadn't specified the data here, I would have to specify it there. But because I've already specified it, I don't. Now, the mapping, so basically how the data that's inside MPG, if you remember right, MPG has all these different columns, gets mapped to the display. So this is pretty easy. We say mapping the aesthetics. X, it will be equal to the displacement. So that's the engine displacement. That's what we got down at the bottom here. And Y will be equal to the highway mileage per gallon, HWY. And up comes my plot. And you can see I've got sort of exactly what I've got. And these plots in this PDF file are actually the R plots. We can do the same in R here. If you'd wanted to see that, we can say, okay, ggplot. You'll see there's very little difference in the syntax. So we got data again equals to miles per gallon plus we're going to add in the geom point mapping equals the aesthetic x. X will be equal to the displacement. And now, because of the way R works, I don't actually have to quote displacement like I did here. So that's the one difference. The Python language syntax is a little more restrictive. So quite a bit of time when you transfer something from the R over to the Python, you just have to turn a bunch of the parameters into strings. Sorry, I just pulled it up on another screen here. Yeah, so there's the same thing in R. Now the item returned by these here, let's just assign this to a value. Just say, let's call it P for plot. Is actually an object, and its default printing prints this. If you try and call print on this object, it'll pop up the plot. There's also a draw function which will do the same thing. So we can call draw on that. That pops it up. If you want to save it to a file, here there's a save routine. There's a variety of options here, but I could just call it basic.png or PDF, whatever you want. There we go. And now if I load that into my Emacs, you can see there, that's the image. So that's written that out into an image. And you can pass different arguments and stuff to set that up as you want. But so that's the basics of the ggplot. And so just returning down to this here now, we can see this has completed. I'm in the Plotnine environment. So if I fire up Python, it'll be using the stuff installed in that environment. And now I can say from Plotnine import asterisk. It's a little slower because on my machine it's coming off an SSD drive, and on this machine it's many files coming off of the shared network file systems. And Plotnine is actually built on top of matplotlib. So with these plots here in Plotnine, you can do all the standard matplotlib stuff you're used to doing as well with them. There you go. And now you could do plotting. I'm going to stick with my bit of a semi-graphical environment here. I'll show you an example here too. If we go back up to this previous one here, I'd mentioned you could put this in either position. So the parameters you want, because you can add many different things to your plot, the parameters you want to make a default, you just put them all in the ggplot, and then that saves you having to type them in again and again and again. But this would be perfectly good. And I'm not quoting MPG because MPG actually refers to this pandas data frame where there is no displacement variable. So if I didn't quote these here, Python would complain that it doesn't know what displacement or highway is. ggplot knows to look them up inside the provided data frame. Now, yes, and I assign that to P. And for whatever reason, once I close my first window in this situation here, I have to explicitly call the draw to get them to show again. But So there we go. Let's have a look at the next one here. Great. I had a slightly more crazy one. I could also put all this stuff here, right? Because this is how we can specify the defaults. I could make those all default parameters by putting them in the ggplot. And then I don't have to specify anything to my geometry. And we'll just as another example of how you do it. So basically you can stick whatever you want in this ggplot call to make the defaults for the next, the geometries and such that you add to it. So let's have a look at another plot here. So this one here goes into a few more aesthetics mappings. In this case, in the original one, if you remember right, we just had the aesthetic X and Y, which is basic aesthetics on a scatter plot. This one here, we've added an aesthetics, a color aesthetic as well, and we've assigned the class. So this is the class of vehicles. This is the miles per gallon information collected, or a subset of it collected by the U.S. Environment Protection Agency for, I forget what the years were. So if we want to, let's do up this plot here. I'll just go back to my previous ones. I usually like to put the actual, because usually you only work with one data set. So I like to put that in there. So we'll just stick that back in there. And the settings X, Y, so we'll just add another setting here, color. We will assign that to be the class. Oh, and I'm assigning it to P as well. So we have to do a P draw command. And here we have the basic same plot. Now, probably notice that it's chopped off the class information on the right side. And that's actually a feature, I looked that up. That's due to the way that matplotlib handles subplots. So I believe it's actually put these in as two separate subplots. So there's some tweaking you can specify as to how much the main plot of your space it takes up that will reveal that. And I'll show that to you now, but we'll get into the details later. So if we add to the P and we add what they call a theme adjustment, so this is jumping a bit ahead, but just so you can see this. And this, again, with the nice, see, I assign this to P, I can continue adding stuff to it easily here with just using this P plus syntax. So if I wanted to, I could say P equals P plus theme. And then we're just going to provide a subplot adjustments option to the pass it to matplotlib adjust. So there is no sort of equivalent to this in the R side because R is not using matplotlib under the side. So we're just setting that main plot there to take 70% of the window, its right-hand side, which will free up more space for the class specification on the side there. Let's do a draw on that. There we go. So that's the first of a little bit of a minor annoyance that you have to deal with, but it's not too bad to correct it. But as soon as I just Googled that, I couldn't see my legend. It brought me right up to the issue on GitHub where they had discussed that. And they said that was just a limitation of having built it on top of matplotlib. So you have to sometimes tweak this to get the layout you want, which is the point of the themes, right? The themes, you can easily add stuff that tweak various aspects by just adding a plus theme. Anyway, so there is a basic plot. Now this one here, miles per gallon, is actually a horrible measurement of vehicle efficiency because there's, you know, it looks like there's a big difference here between like 40 and 30, but in truth, there's a much larger difference here between 10 and 5 than there is between 40 and 30 in terms of your fuel consumption, right? If you go from 10 miles per gallon to 5 miles per gallon, or whatever this sad little one SUV down here at the bottom is, you're going to be consuming twice as much gas. If you go from 40 miles per gallon to 30 miles per gallon, you're going to only be consuming another, like I said, probably another 50%. Or sorry, no, that's something else. I'd have to divide those out. 25%, I believe. Get that division backwards in my head. So a much better usage would be the more standard English one, which is how much you actually use per kilometer. So this is liters per, gallons per 100 miles. I didn't convert the English units to metric. And if we go back to our basic plot here, we can actually put basic math stuff in here. So instead of plotting highway, we can plot 100 over highway. So these expressions are ran through this syntax here is actually ran through a small expression evaluator. So you can put basic math manipulation of your parameters in there. So let's run that. Oh, and I'm still assigning this to P. So P draw. And there we go. And you can see it's doing nice stuff for the labels too, right? By default, it picks up my expression for my label. And again, I could do the same thing here to give this, cut down this one here to give a little more space to my labeling over on the side. And now in this one here, you can really see like this was the fuel hog here. And you can see there actually isn't that much difference between these ones here on the low end. And you can sort of see some of the data here too. If you look, we've got mostly SUVs and subcompacts up on the top here. And then down on the bottom, again, we have the smaller cars. And there's a few exceptions here that have large displacements and I mean, not horrible gallons per 100 miles, but definitely using a bit more as our sports cars. So that's the 2-seaters. Oh. Now, faceting is one of the things I really like about the whole ggplot libraries. And they do it very nicely. And basically, it just lets you do the same plot again, but to actually break your data into subsets and plot them and show them. So this here is the same plot we've been looking, but we're faceting by the manufacturer. And then that gives you a nice, easy comparison across your data. And it's super easy to do in ggplot. Let's go back up here. Let's see if I can do this here nicely. So I think Python will continue my expression. Yes. Oh, it's not going to be happy with that. So we got that, and then we're going to add to it that, which is my basic one. And there's actually, on this particular one here, these dots have to be relatively small. So I'm going to also set a variable here, size, and I'm going to set it to just 0.5. So all of these things too, you can, so the aesthetics, when you specify it in a mapping, then it's tied to the data. You can also just give it static values outside. So if I wanted to, I could say color equals red, right? And then all the points would get the color. If I put it inside this aesthetics option here, and as part of the mapping parameter, then that derives, each one has a different value based on the data. If I put it outside, then it applies to everything. So you can make your size, like if you want to, you could say size equals some other function of these, like the transmission type or the model or something like that. There we go. And now if we want to add a facet, there's a couple different faceting functions we can add. In this case, I'm going to just use the facet wrap. You can have, your facets can have two parameters. You can have an X and a Y location. The facet wrap just has one parameter and it wraps around based on the space. So facet wrap, and the facets, we're going to facet by manufacturer. And there's a couple different ways of specifying the various facets. So I'll return to that. So I'm going to just complete this expression here and assign that to P, make sure, there we go, P dot draw. I will correct the spelling of my manufacturer here. Manufacturer, there we go. P dot draw. So there we have the same plot. Here's the same plot in R. So there's, what I was going to tell you was there's a couple different ways you can specify. Let's go back to this one here. These, the facets. So if I'm using like an XY facet, then I can specify X, the X value, and then the Y value, whatever I wanted to, the other thing I wanted to facet it by. So for example, like the transmission. Facet, that would be a grid facet. And then you can see, I mean, this is not particularly legible, but it has made up the plots here. We got the auto manufacturer across the top, and then the different transmission types along the Y side. So there's that style of writing, and then there's also the old style, which has sort of been deprecated. You can do a, let's bring this back up here again. There's a special syntax which comes from the R modeling language, where you do this little tilde. So it's basically Y is proportional, if you will, to X. So this side here would be the Y side, if I remember right. And this side would be the X side. So if we went back to our facet wrap, facet equals, and in this case, there would just be, whoops, just the manufacturer. I think if I did that in the old style, we'll see how happy it is with me. P dot draw. Yeah. So you might see this kind of strange tilde, and basically that just separates the X from the Y. And in this case here with facet wrap, there isn't really an X or a Y, there's just the one. But if you're doing the grid of facets, then it would be the one tilde the other, as opposed to specifying them separate. And now if you did the same thing in R actually has, with R, you would you'd make a vars call, and then you'd put the values in it. So it'd be vars manufacturer. If I did the full call, I'll just go back to the previous ggplot, geom point. So we have color equals class, and then we'd add in the facet. Facet wrap, and then we would do facets equal, and then we do vars, and in this case it would be with that one. And that's the exact same thing. So in Python, instead of saying vars, you just, because they're strings, you can put them in direct quoting. Vars is actually a special function that correctly wraps these up for them. Okay, anyways. So there's just some very minor differences. Let's have a look at some more geometric options here. Geometric objects. So this particular plot, again, is the same data plot, and then we've added a line of best fit through that. And as I said before, you can just keep adding your geometries. So let's do P equals, I'll go back up here to, we'll do our basic P here. We'll go back to full size, there we go. Oh, P equals, we'll have to add the ggplot first, with the data equaling the miles per gallon table. There we go. And then to P, we're going to add in, so I mean, we could draw this P dot draw. There's the basic P. Now we're going to add to that, so we're going to add in some more geometry. Let's add the geom smooth function, which does a smooth sort of fit. Now, okay, I'll get to this in a moment. So we got the, again, we want to use the same sort of mapping here. X is equal to the displacement, and Y is equal to the 100 divided by the highway miles. And in this case, for the smoothing, we want to just smooth on all the points. We don't want to have separate lines for depending on what class the cars were. So we're not going to include a color split in there. There we go. And then we will draw, oops. Save that as our new P, and then we will draw it. And we have the sort of Plotnine equivalent of it. And you'll notice that this does not actually look exactly the same as this. And that's to do with the underlying function it's using for the smoothing. This one here had a best fit. I forget what it is, some sort of moving thing. And this one here has a different one. So R has a bunch of built-in statistical functions. It's sort of the language of choice for statisticians. So it generally supports statistics better than Python. Python looks like it's given me some sort of line of best fit. It's allowed it to vary. So I don't know if it's done some sort of spline or something in there, but that gives you a difference. And back on the bottom end here, there's not actually a whole lot of points. So the R is letting this one here drag it down. You can see the uncertainty bars going sort of up there. And on Python here, it's obviously is considering values over a larger area. Yeah, so you should, I guess the lesson is you should know a little bit about actual fitting function before you get too excited on fits on areas with low data. But down in this region here where we have lots of data, you can see we got some fairly good agreement between the two. So anyways, that was an example of having extra data. And you see the way we do it is we just add additional geometry. So People, if you're coming from a different background sort of in your thing, you're used to there being a separate, maybe a separate function you call for each type of plot. But the whole point of the grammar graphics is you can just describe it in more and more details. You just add in the sort of details you need, and you can add all sorts of geometries, put them all on the same plot. Yes, and this also here brings up another issue, which, as I said here, you can see I'm specifying here, I've got the aesthetics displacement over the Hawaii, and I've got the same aesthetics here specified twice. So this would be a typical example where you might actually, if we go back to this, we'll put this whole thing in here again. So P equals GG plot. This might be the sort of case where we actually want to specify some of this stuff up front. So we can set those as sort of the default aesthetics. And then to that, we can add the line. And depending on this particular one here, you can see I actually put the line call in first. It's underneath. So let's do the same here. That other one I had not. So we're going to add to that geom smooth. Now, because these aesthetics are the default aesthetics, I do not have to specify them. So we can just leave that like that. And then we're going to add in our geom point. Point data. And then again, X and Y are already been assigned. So the only thing I have to add in here is to say, oh yes, and we want the class color there as well. So there we go. And then I've got a typo here because I have a plus here and a plus there. So I'm going to have to re-enter that. P, and then we can draw that. So basically, you can see here's a small example of where you might want to start specifying more bits. And of course, you can override these in the individual ones too here. I could have added the color in here as well. And then in this case, when I would do the smooth, I'd have to undo that. I'd have to say the color is equal to none to stop that mapping. Okay, so let's have a look at the some statistical transformations next. So as I mentioned, there is actually a statistical transformation that was occurring with this plot here, the smooth plot. It was running that through a function. But you can also call stats. So most of the objects have both a stat version and a regular version, and the one emphasizes stats parameters, the other emphasizes the geometry parameters. So you pick which one, everyone is most convenient, but you can actually specify the two. You can do both of them as well. So let's do another here. You can do with the other. So GG plot. Let's get our data back up here again. Miles per gallon. And in this case, we're going to add to it the geom bar. And the geom bar, each of these geometries has a default statistical transfer. The point one, the default statistical transfer is the identity, so it doesn't actually do anything. But the geom bar, I believe its default wants to summarize them by counting however many objects are in that class. So in this case here, we will do our mapping here again. Mapping equals aesthetic. We're going to assign X to the class, and we're going to assign the fill to the drivetrain. So four-wheel drive, front wheel, or reverse. You draw. So there we got the basic same sort of plot here. And you can see they've this with the under Python, you don't get the dynamic adjustment between these two here, but it does fit nicely if you just have a few letters on the side. So I guess they made the minimum sort of the default. These ones here have a nice black outline. I can add that in here as well. So go back here. So we want a color equals black. The original ggplot was done by Haley Wickham, who I believe was from the UK. So it supports both the American and the UK/Canadian spelling if you want. There you go. So now we've got the same sort of item there. And as I said, there is, so these geom bar, there's an equivalent one here that emphasizes more the stats. So if you want, you can do, we'll just go up to here. You can also get the same thing by saying we want the stat count. So each geometry has a default stat. In this case, geom bar, the default stat is the count. Each stat has a default geometry, and the default geometry stat count is geom bar. So they actually specify the exact same thing. But when you add additional parameters in here, it's nice and easy to add them for the statistics if you're calling the stat function, and it's nice and easy to add them for the geometry if you're calling the geometry. So you just use whichever one is most convenient. And we'll do the same, plot this again here. There we go. And when you're actually trying to come up with your plots, probably one of the easiest ways, I just bring back my website here again, is I like the ggplot documentation. And then if you go into, let me see, reference, they have all the sort of things here. So like say we've looked at geom point before, and you can scroll down and they have a huge number of example graphs. So here they're setting the set at various sizes and so on and so forth. So traditionally the R documentation has been better than the Plotnine, but the Plotnine documentation I was looking at again here is getting a lot better. So here's Plotnine. They have a gallery, which is kind of nice. API, so the geoms. So on the R1 there, we were looking at geom plot point, pardon me, there we go. And Plotnine actually has a reasonable number of examples itself here. Actually, it looks like it's using the same same data set as I'm showing you here, the highway. So a perfectly good way of doing these things actually is just to go there, you know, roughly what sort of graph you're looking at, look up the geometry, scroll down, and you'll find an example that's probably reasonably close to what you want to plot, and take it from there. So this was a position adjustment example. So as you can see, these positions here, it has the data, the count stacked on top of each other. You can easily switch that to not being stacked on top of each other. So let's use the use this one here. So the side by side is called a dodge position. So I'll just set the position function to equal dodge. Draw that again. Oh, I was going to show you two as well. Let's just go back. We'll do one more here. If we go back to, actually, we can do that on this last one here. This one here, we can actually specify what our values are as well. So we can say y equals, now the y value is calculated from the statistics. So we want to look at the values after the statistics are calculated. So we can say after stat, and we want to get the count value, which is going to be added because that's the default statistics. And then we want to say the sum of the count. And then my y values, instead of being just the count, they'll be a percentage, right? So your particular count is actually will be a vector of values broken out by basically categorized by the remaining variables, so the fill and so on. And then we're going to divide it by the sum, which will be the total, which should show the percentage. So let's have a look at that. Okay, yes, we got that here. Let's go P equals, I lost my original one here. So data equals MPG. And now I'm missing a matching bracket. So it'll be after this stat one. I probably did not. Yes, close the aesthetics. Okay, I just have to break that out into multiple nines. P equals ggplot. Okay, fill is equal to the DRV. Sorry, here we'll get this right yet. Color is black, position is dodge. P dot draw. There we go. And now along the side here, you can see it's accessing the stats value. So instead of having just the total counts, we have the percentage over the total of the sum of all the values in that classification. So again, in this particular case, count is a vector and it's been broken out by the drive chain and whatever particular value of X we're on. And then so we're taking that vector and this will create a new vector, which will be that count vector divided by the scalar, which is the sum of the total. So for each of these bars here, that will give us the percentage for it. So that's how you get the final graphic out of that. There's a coordinate system one here. This is a ggplot. R1, as it turns out, the polar coordinates is not something that has been implemented inside of Plotnine yet. So that's still a to-do one, so you can't duplicate this one. Pie graphs are notoriously horribly bad anyways, because your eyeball has a very, very hard time of doing comparisons across them, even though they look really cool. This looks cool. So then how do you adjust the scales and labels I wanted to talk about? If we just go back to our plot here, this looks like just our standard. I'll go back through my commands here. So we have a basic plot. Right. So I specified everything inside a ggplot there, so there was no geometry associated with it. So we need to get a geometry up here. So geom point. There we go, and we'll put the color as the class as well. One more time, we'll have this correct. color equals the class. Which gives us our basic item here. And now we can mess around with the scales. So the scales are basically how this, so like this here, of course, would be a linear scale, sort of the default scale. The color, I believe the default color is to take the values of the hue and chop them up into however many points you have, which is not a particularly, the hue parameter color does not map well to sort of equal intervals to equal observations. So you can use your own color scales. So instead, we're going to use the Brewer scale as an example here. So we can use color. There's a variety of color scales, as you can see, to choose between. The Brewer is a nice color scale. It doesn't have so many increments, but we'll use the qualitative because it's been adjusted to, it prints well in black and white. The items are distinguishable between people with color blindness. So if you have color blindness, you probably have a hard time seeing the difference between the green and the red ones. Whereas the Brewer scale has been adjusted to have that. So the qualitative Brewer scale is what we want. And we'll just draw that. There we go. And in this particular one up here, I see I've actually jittered the points as well. So we could add that in too. So we'll position equals jitter. And that just adds a little bit of random noise. So the ones that are sitting on top of each other, they break out. So when you don't have that, you don't actually see that there's many different points here because they just all get plotted on the same top of each other. Now, if we wanted to, another option here, when we were originally passing the Y, if we do a log scale, for example, that would let us convert that into also see those relative differences better. So we can do a P, we'll add in the color Brewer scale. There we go. And then we will add in a log scale on the Y. So we can say, okay, scale. If the values you don't specify get the default, right? So you get just the linear scale by default, but this lets you easily override it. And then we will draw that. There we go. And now you can see it's expanded out this range of 20 here. So you can see this huge difference between, I don't know what this thing gets, 1 mile per gallon. And then it's compacted these down here. So you see there's not actually that much difference between them because log scale equal spaces equal relative distance now instead of absolute difference. If you want, you can, I guess, watch the previous one. So here's the log scale we talked about. Here I turned off the legends. You can remove those. Here I've went ahead and I've actually specified a different scales. So there's labels functions. You can get that easily, makes it easy to start putting in the information. They're just, again, they're the same sort of thing plus. Now Python does not let you set a subtitle. That's also a requested feature that hasn't been implemented yet. And then the themes basically is kind of like your desktop, right? You can theme it. So in this case, we've used the minimal theme. So it's sort of really reduced any additional coloring. And then I've adjusted the position of this vehicle class in the other side as well. And again, you just do that with a plus theme and you specify the various elements of the theme you want to modify. And then here's an interesting plot showing some creativity. This is the same sort of data where we've broken it out by manufacturer and then their list of cars. And then we plotted their miles per gallon along the axes here. So you can really see how they stack up, or pardon me, their gallons per 100 kilometers broken out by manufacturing. So you can get some really creative plots if you do it. So mostly people ask, oh, how do you do this to plot? Well, you just have to think about it, and the grammar graphics lets you do it In this particular plot, this uses a scale equals free function, which is also not implemented in the Python version, so you can't quite get this. It'll put these the same size when you do this in Python. So Chevrolet, for example, have the same size as Audi, even though Chevrolet has more data points. So the Audi ones will be a little larger. Anyway, so that completes the talk.